Deep in Pharmaceuticals in association with Higher Secondary Principals Forum.
Hello learners, how are you all? Hope you all are good at your end. Even if situation is not better, even if situation is not under your control, don't just get panic. Just calm down. Analyze situation. Make optimal use of whatever resources you have. With proper precautions and proper planning, you try to solve your problem. Surely you will come up with new condition or better new condition. Now why I am telling this everything? Because this mathematics subject teaches you very important life lesson, that is, don't get panic. Whatever situation you get, just calm down, use your resources and your all methods and face the situation. You will surely come up with a solution. And that's why this mathematics subject is called as Queen of all sciences. So, learners, you are special. Why? Because you are learning this mathematics, which is Queen of all sciences. You will able to do all other subjects if you learn mathematics very well. Okay? So, with this motivation level, let us start with today's chapter, continuity and derivatives. So, basically this chapter is divided into two parts, continuity and derivatives. So, what I will do is, I will first see continuity. First we will discuss all methods, all problems based on continuity, and then afterwards we will proceed with another part, that is derivatives. Okay? Now what is continuity? Basically, continuity word itself tells you something which is very smooth, something where there is no break, there is no jump, there is no bump. So, what is continuity? It is a smooth curve, or it is a smooth flow of any event without any bump, without any jump, or without any break, right? So now in mathematics we will be studying about continuity of functions. Now students, you must have learned relations and functions, and in that chapter you must have come across many functions, many type of functions. For example, polynomial function, trigonometric functions, exponential functions, logarithmic functions, and many more. Okay? So what we will see here is what is continuity of function. Now to say the function is continuous, to say any particular function is continuous, what we supposed to see, that is three conditions, that is limit x tends to a plus f of x. Second one, limit x tends to a minus f of x, and third one, that is f of x equal to a. Now here obviously you people have seen limit operator, here also you can see limit operator. So basically here we are proceeding further from our limit chapter, what you people studied in your 11th standard. So learners, if you have strong base of your limits chapter from your 11th standard, surely you will able to do better job over here. Okay? So let us start. Here, as I told you all, continuity is something which is the curve which is very smooth. So to understand this definition, continuity, at one point, that is x equal to a. So remember, we are checking continuity of given function, that is y is equal to f of x at x equal to a. So here I have three conditions, three graphs with me So over here this is graph number 1. So if you look at this graph, here I have this function with me, and now if you see at x equal to a, here this circle signifies this function is not defined at x equal to a. Okay, the first condition over here in this particular graph says this function is not defined at x equal to a. Let us see left hand side of this function. So if you see left hand side of this function, you can see smoothness, there is no break, there is no jump, right? So you can say in this left hand side the curve is smooth. So I say over here limit x tends to a minus f of x exists. Okay, so first condition got over. Let us look at the second condition. The second condition tells me that here towards my right hand side, again I can see smoothness over here for this curve. So I can say the given condition, that is limit x tends to a plus f of x exists. And when you go to my third condition over here, f of x tends to a, here what we discussed? We discussed that at x equal to a, the function is not defined, right? So there is a jump, there is break over here in this particular function. So obviously this particular curve or this particular function is not continuous. By observation itself, you can make out it is not continuous. So which three conditions we discussed? The first one, this exists. The second, this also exists, but here third one does not exist, or you can say third one is not defined. Okay, so let's go to the second one. Now if you look at the second one over here, you can see the curve is smooth. The curve is smooth. So over here I can say the left hand side, so x tends to a minus. So all the negative values of a is giving me smooth curve. Perfect. Now if I go to the right hand side of the function, this curve again it is smooth. So obviously limit x tends to a plus f of x exists and it is smooth, and you can see the flow is continuous. So I can say here first condition is equal to second condition. But if you look carefully to this point here, at x equal to a, the function here exists, but it is not equal to the limit x tends to a plus f of x and limit x tends to a minus f of x. So here you see this particular plotting, this particular point is not on this line. So I can say this particular curve or this particular function is not continuous, just because my left hand limit and right hand limit equal, but it is not equal to f of a. So we finished with the second case. Let's talk about the third case. So here when you talk about third case over here, by graph itself you can see the curve is not continuous. In normal language I can say there is break, there is jump, right? So I can say the given particular function is not continuous. Now let's see mathematically. Now you can see over here, look at this curve here. See, this is continuous. See, from here to here. So this is my left hand limit. So left hand limit exists. Okay. So I can say it exists. My right hand limit also exists, but it is not equal, right? So the major condition over here, what I can see is limit x tends to a plus f of x, that's my right hand limit, and limit x tends to a minus f of x, that's left hand limit, is not equal, and hence I can say here this particular graph or this particular curve is not continuous. Okay, so we have seen three conditions over here. You can see the curve is nicely smooth over here, but at this point it is not continuous, there is a break. So, it is not continuous. Here the curve is smooth, my left hand limit is equal to right hand limit, but it is not equal to f of a. So, that is why it is not continuous. And third case we came across here, that is by observation itself you can make out the function is not continuous. Why? Because there is a jump, or you can say there is break in the curve. Okay? Let us go to the fourth condition, which is very crucial over here, that is, now if you see this fourth graph here, now you can see this graph here, see this line is, this curve is going towards infinity, right. So, now over here I can say my left hand limit. So, I talk about this a minus left hand limit does not exist. Why? Just because it is going towards y axis, right. So, this limit does not exist. And if you see this curve here, see at x equal to a, it exists, and which is equal to my right hand limit, that is here this curve. So, I come to the conclusion over here that limit extends to a plus f of x, that is this curve, which is equal to f of x equal to a, that is this, but my left hand limit does not exist. So, again, hence if you see this graph by observation itself, you can say the given particular function is not continuous. Okay? Let us go to the another situation over here. Now, let us talk about this situation. Now, you can see the similar curve is here. So, if I talk about my left hand limit, you can see it is going upward, right. So, whatever I discussed over there, limit does not exist. So, over here limit x tends to a minus f of x does not exist. So, again, since this curve also going upward in upward direction, my right hand limit does not exist, and hence I can say by observation itself the given curve is not continuous. So, to brief this all four conditions, we have seen four different cases where our curve is not continuous. Okay? So, here we come up with this three conditions, right, and we discussed that if these conditions are existing, if these three conditions are equal, I can say my given curve under discussion is continuous. Okay? So, let us discuss the definition of the continuity of a function at x equal to a. Here, continuity at a point x equal to a. Definition says a function f of x is said to be continuous at x equal to a if these four conditions we have to consider. The first condition says f of x equal to a is defined. So, there is supposed to be a proper value for it. Second one, limit x tends to a minus f of x exists. So, there should not tends to infinity. So, this is a minus signifies this is left hand limit. So, I am talking about all the x values which are less than a. So, over here I am talking about this curve which is towards the left hand side. So, we are talking about limit value of that particular curve that is supposed to exist. The third case, limit x tends to a plus f of x exists. So, over here this is your right hand limit. So, we talk about all the x values which are greater than a, and so we talk about this curve from here to here. So, you can see it is smooth, here you see this is smooth, and it is here, see if you see this critical point, this is perfectly smooth at this particular point. Why? Just because this fourth condition is satisfying. That is, limit x tends to a minus f of x is equal to f of x equal to a, which is equal to limit x tends to a plus f of x. So what I want to say is my left hand limit is equal to f of x equal to a, which is equal to f of here limit x tends to a plus f of x. So this is the definition of continuity of a function at x equal to a, at x equal to a. Now this value can be any number, it can be 0, it can be 1, 2, it can be in radians, it can be pi, pi by 2, it can be any value. Fine. So if you talk about this definition can be asked directly for 1 mark as theory question. So if you give the entire thing, all 4 conditions, you are through, you will be getting entire 1 mark. Okay. What happens if the function is not continuous? So obviously the given function is discontinuous function. So the denial of continuity is discontinuity over here. So obviously whatever condition we discuss, there will be imbalance over here. So here we are discussing types of discontinuities. Okay. So over here we have first kind of discontinuity, that is a removable type of discontinuity. What does it mean? Now over here look at this. This is a balanced equation. Now here what is happening? The left hand limit is equal to my right hand limit, which is equal to f of a. So there is imbalance which gives here this kind of discontinuity. Here my left hand limit is equal to my right hand limit, but it is not equal to f of a. Let me repeat again. Right hand limit is equal to left hand limit, but it is not equal to f of a. So here you see limit x tends to a minus f of x, whatever value you get, that will be equal to the second, but it won't be equal to this value here. So if you look at this graph, you can see this value will be equal to this value, but it won't be equal to this value. So basically I am talking about my second graph which we considered before. So over here the curve is smooth. See, the curve is smooth. You can see the curve is smooth over here. My left hand limit is equal to right hand limit, but at x equal to f of a is not on the curve. This point is not on the curve. So hence I can say it is removable kind of discontinuity. Now why it is called as removable kind of discontinuity? Just because f equal to a, whatever value you get, you are getting imbalance over here. So if you remove that value and you place whatever value you get over here, then your situation will be proper. So I can say you can remove that discontinuity factor and you can make your function continuous. Perfect. Let's go to the second kind of discontinuity. Here it is called as irremovable type of discontinuity. So by name itself you can find out here your left hand limit is not equal to right hand limit, right? So since left hand limit is not equal to right hand limit, we consider all such points over here which are interconnected to each other, so you cannot remove that imbalance creator, right? And hence you cannot remove that discontinuity factor, and that's why it is called as irremovable type of discontinuity. Fine. So the definition goes here. So if limit x tends to a minus f of x is not equal to limit x tends to a plus f of x, perfectly it is irremovable kind of discontinuity. Now let us discuss about fourth graph which we considered before, that is Suppose your left hand limit does not exist, or suppose your right hand limit does not exist. If this situation occurs, then that can be what kind of discontinuity? So over here we have seen this graph. If you remember here, see, and here we talk about x equal to a, this is your x, this is your y, this is your origin. Now look at this graph, we discussed this graph before. Now you can see your left hand limit does not exist, your right hand limit also does not exist. So by observation you can say it is discontinuous, the given function is discontinuous. Now the question is what kind of discontinuity it is. So it is here irremovable kind of discontinuity. Why? Because it is irremovable kind of discontinuity just because the limit itself does not exist. Okay, so over here if you get this kind of situation, if you get the condition where your left hand limit does not exist, your right hand limit does not exist, or both the limits does not exist, again it is what kind of continuity? Discontinuity. It is irremovable kind of discontinuity. Let us discuss problems based on what we have learned. Just now we discussed continuity of a function at x equal to a, and this is very important definition we come up, that is limit x tends to a minus f of x is equal to f of x equal to a, that is equal to limit x tends to a plus f of x. So basically left hand limit is equal to f of a, which is equal to right hand limit. What I will do is, here I will consider different cases, and these cases are based on different situation what we will come across. Now over here if you look at this particular function in this particular problem, the problem is examine the function f of x which is given by this for continuity at x equal to pi by 2. So I need to discuss continuity of this particular function which is given to me. Here if you look at this particular function, my left hand limit is equal to right hand limit. See, the left hand limit is equal to right hand limit, and the another value is given to me here at x equal to pi by 2. In general we say at x equal to a. Now in this condition we are discussing continuity at x equal to pi by 2. Okay, so here examine whether, that means you are not sure the function is continuous. Now we are finding out whether the given function is continuous. So keep in mind, this is what I need to prove. If it is continuous, if it is discontinuous, there will be imbalance, or these three values will be not equal. Perfect. So let's start. Solution. So over here we supposed to discuss continuity at this particular function, and just now I discussed over here this case here my left hand limit is equal to right hand limit. So what I will do is I will say limit x tends to pi by 2 plus minus. This is very important. Plus minus. What does it mean? My left hand limit is equal to my right hand limit. So both the conditions I am considering over here. So f of x which is equal to, what is the here, see, at x not equal to pi by 2, what function is given? What definition is given to me? The definition is here. So I say limit x tends to pi by 2 plus minus cos x upon pi by 2 minus x. Look at this now. This function is trigonometric function, and in trigonometric function, this is in trigonometric function, here we use substitution method. So when I say I am using substitution method, I say put x equal to, what is my limit value? Pi by 2. So I say pi by 2, since my variable x is negative, I say minus h. So over here say as x tends to pi by 2, my h tends to 0. This is very important. I say x equal to, this is what is my substitution over here, x equal to pi by 2 minus h, as x tends to pi by 2, h tends to 0. Now over here see what this plus minus signifies. Here this plus minus will have no role in the problem. It's just a symbolic representation to tell this is your left hand limit as well as your right hand limit. Perfectly fine. So let's proceed further. Let me substitute x equal to what I have considered in the problem. So I will get limit h tends to 0. See, h tends to 0, right? So I will get cos, what is x? So I get pi by 2 minus h upon, so I get here pi by 2 minus pi by 2 minus h. So obviously when I open this bracket, this and this disappears, cancels. So over here I get limit h tends to 0. Look at this, cos of pi by 2 minus x. So there is pi by 2, cos will change to sine. So I will get sine h upon, now here minus minus will become plus. So I get something like this over here. Okay. So here you know this is very important formula in substitution method what we use. So the answer what I get is 1. So this is my equation 1. You got my equation 1. So over here let us talk about the second condition. So what my second condition is? The second condition is f of x equal to pi by 2. So at x equal to pi by 2, you don't have to worry about, the value is given. So what is the value? 1. So this is my equation 2. So here I get my equation 1, here I get my equation 2. Okay. What we are finding? We are finding whether the given function is continuous. So we come at this definition, check now, limit a minus f of x is equal to limit a plus f of x. Yes, it is 1. Here at x equal to pi by 2, what is the value? It is 1. So I say, since limit x tends to pi by 2 plus minus f of x, which is equal to f of x equal to pi by 2, that is equal to 1. F of x is continuous at x equal to pi by 2. So we proved that, or you can say we concluded that the function is continuous at x equal to pi by 2, just because you are getting 1 here and you are getting 1 here as well. Let us go to the second problem or second example of case 1. Over here again, why I said it is case 1, because we are dealing with same kind of function, if you see, where your left hand limit is equal to right hand limit, which is already given to you all over here, and here at x equal to 0, at this point half as value which is given. Okay. So over here we will be proceeding same way, but remember here show that. Show that in the sense what? This is true statement. You are no one to deny this statement. It is continuous. So anyhow you show that it is continuous. You cannot say it is discontinuous. Okay. So now the same problem I am writing in this way. Look at this. If f of x equal to, the same function is given, look at this here, e raised to x minus 1 log 1 plus 2x. X is not equal to 0, the same thing is defined. Is continuous at x equal to 0, find f of 0. Find f of 0. They are saying the function is continuous. Okay, so when they say the function is continuous, what does it mean? It means your left hand limit is equal to your right hand limit, which is already given over here. It is also equal to your f of a, and at this moment it is f of x equal to 0. Okay, so let's proceed further with the solution part of it. So when we proceed further with the solution part of it, since it is continuous, it is given the function is continuous, I will write since the function f of x is continuous at x equal to 0, limit x tends to 0 plus minus f of x is equal to f of x equal to a. So at this moment, what is my a? 0. So this is what is your theory which you are writing. And it is very important to write. Why? Because you are using your theory in your problem. And that will be the start point for this particular problem. Now let's proceed further. As we know, this is my, so limit x tends to 0 plus minus e raised to x minus 1 upon log of 1 plus 2x. Okay. Now here if you look at this situation, this particular function is combination of your exponential function and logarithmic function. So basically we are dealing with finding limit of exponential function as well as logarithmic function. So here these two formulas basically we are talking about. So limit x tends to 0, it is a raised to x minus 1 upon x. So if you get something like this, it is nothing but log a. Just remember whatever x you have over here, whatever variable you have over here, the same variable supposed to be present over here. Then only you can write it as log a. And the second one, that is limit x tends to 0 log of 1 plus kx upon x, if you get, it is nothing but k. So this is the second formula from logarithmic function we are considering. So let us proceed further. Now look at the numerator part. So if you look at the numerator part and look at the first formula, clearly it is visible. I want x in the denominator. Here also in the denominator I want x. So what I will do efficiently, that is I will divide numerator and denominator by x. This is the key point to note. So what I do, I divide a numerator and denominator by x. So here we go. So we are getting limit x tends to 0 e raised to x minus 1 upon x, the whole divided by, here I get log of 1 plus 2x upon x. So what I am doing is I am dividing numerator and denominator by x. So if you look at this, the limit of this, see, a raised to x minus 1 upon x, I get log a, but instead of a what I have? E. So what will be the answer over here? The answer is log e. The whole divided by, now limit x tends to 0 log of this. Compare this with the formula what you have over here. What is there in place of k? It is 2. So you get as 2. Just the implication of these two formulas. So what is log e? 1. So you get 1 by 2. This is your equation 1. Now let us talk about the second one. So what is given over here? Now if I talk about my first problem, what is your f of x equal to 0? Your f of x equal to 0 is half. So I am done with my first problem. Perfectly fine? Okay, so let's proceed further with the second question. It is same, but now since it is given in this form, I need to prove this is equal to this. So I say f of x equal to 0 is equal to half. So I am saying this is my first condition, this is my second condition. So I say over here, limit x tends to 0 plus or minus f of x equal to f of x equal to 0, which is equal to half. So you say f of x is continuous at x equal to 0. Okay, so basically the problems are same. Basically we are coming to the same conclusion, but the framework of the problems are different. So hence, you see it as different way, but the solution remains same. Let us talk about second condition. Here if you see second condition, the function over here, you can see here 3 cases which are given to you all. The first case, here this function is defined where your x values are less than 0. Here this value is defined when your x is equal to 0. And the third equation, the third function is given for all the values which are greater than 0. Right? So here if you look at the main definition of your function, you will see the different function you have for your left hand limit, that's this. The different function you have for your right hand limit, that's this. Now why this? Because here you consider all the values of x which are greater than 0. Okay? Now why for left hand limit we consider this function? Because here we consider all values of x which are less than 0. So basically here we have at x equal to 0 1 point, that is 5/2. Here I have, this is my right hand limit. So which function I consider here? That is log of 1 plus 3x upon e raised to 2x minus 1. Okay, this is very important for you to understand. And for left hand limit, which function we will consider? That is sine 3x upon tan 2x. Here we go. So because here you have all x values which are less than 0, we consider this function. Here we have all x values which are greater than 0, so we consider the third function. Perfectly fine. So if you able to make proper choice, I think your work will become simple. So first of all, look at the problem, read it, understand it, analyze it, and then you start solving. Okay, now let us read this particular problem. Now what is given to me? Discuss continuity of a function. We analyze this function. So what is our analyzing factor? That is, here we have 3 phases. The first function what you have, that function you will use for your left hand limit. The third function you have, that you will use for your right hand limit. And now let us proceed further for the further things. So we have to discuss continuity. Now what they are saying, see, if f of x is discontinuous, they are not sure whether it is continuous or discontinuous. They are saying in future, suppose the function is discontinuous at x equal to 0, then redefine it to make it continuous if possible. So if it is not possible, then what kind of discontinuity it will be? It will be non-removable discontinuity. So if possible, they are saying if possible. So let us proceed further. So first of all, we need to discuss continuity. So let us discuss continuity over here. So now since I have my left hand limit separate, right hand limit separate, I need to proceed further in that way. So let me start with my left hand limit. So limit x tends to 0 minus. In the previous case what I was doing, limit x tends to 0 plus and minus I was taking together. Now here I will be taking it separately. Why? Because the function which is given to me is different. It is divided into 3 parts. Okay. So over here f of x. Now what is it here? So it is limit x tends to 0 minus the first function sine 3x upon tan 2x. Now here you can see what kind of function it is. It is trigonometric function. So we will be using this formulas. So first formula, limit x tends to 0 sine x upon x, which is equal to 1, and it is also 1 if you have limit 10x upon x. Perfectly fine. Now over here the very important condition what you people need to understand is whatever x you have here, the same angle must present over here. So basically whatever angle you have over here, the same angle must be present over here. Then only you can say it is 1. So let us come to the problem. Now look and see here what is missing factor, that is there is no denominator over here, that's x. Here also you can see in the denominator there is no denominator present over here, that is x. So what is my main step? I will say divide numerator and denominator by x. Okay. So once I do this, I will get limit x tends to 0 minus sine 3x upon x the whole divided by tan 2x upon x. Okay, this is not end of the story. I want 3x. What I have here? Just x. So what I will be doing here? I will multiply 3. So here also I will be multiplying 3. Perfect. Then you can see here I have 2x. I want 2 to appear over here. So I will multiply 2. Here also I will multiply 2. And if you see here what is happening is according to me here this is equal to 1. And obviously this is equal to 1. How it is equal to 1? Using this formula. Okay, now what is left? The left part over here, that is 3 by 2. This is my equation 1. Let's proceed further with the second one. So limit x tends to 0 plus f of x. Second one, so I am talking about, see I finished with my left hand limit, I am proceeding with my right hand limit now. So over here I am saying limit x tends to 0 plus. Okay, so what it is here, the function is here. So I am writing it as log 1 plus 3x upon e raised to 2x minus 1. So same condition we covered in the previous problem. Again it will be revision for you. So over here you can see it is a logarithmic function. Here you can see it is exponential function. So the formulas what you can use over here, that is limit x tends to 0 log of 1 plus kx upon x, and the answer will be k. and the third one, that is limit x tends to 0 e raised to, here it is e raised to kx minus 1 upon x. So basically what we get, that is log e into k. And what is log e? That's 1. So the value over here will be k. Perfect. So these two formulas we will be using effectively over here. So now look, here in the denominator there is x, here also in the denominator there is x. So what we will be doing, the same technique what we used in the previous case we will be using over here. So I say divide numerator and denominator by x. So when I do so, I will get limit x tends to 0 log 1 plus 3x upon x the whole divided by e raised to 2x minus 1 upon x. Here we go. So you can see divide by x, divide by x. Then we proceed further and we use these two formulas effectively. Now what it tells me, you can see there is k. So whatever extra number, extra constant which is present, that will be the answer. So what is the extra constant present over here? That's 3. So here I say the 3 in the numerator, I get 3 here. Now look at the third formula. What is the extra constant present over here? That's k. Now here in this place of k, what you have? 2. Right? So over here what you get is 3 by 2. So we finished with our second step. Let's go to the third step. So what our third step tells us? We need to talk about f of x equal to a. So here I get f of x equal to, what is a right now? 0. And the value is given over here, that is 5 by 2. So here I am getting what it is? 5 by 2. Equation 3. Now compare all these three equations. See, this is equal to this. 3 by 2 is equal to 3 by 2. I say my left hand limit is equal to right hand limit. But is it matching with f of x equal to a? No. Right? So it is what kind of discontinuity? It is removable kind of discontinuity. Why? Because my left hand limit is equal to right hand limit, but it is not equal to f of a. So whatever constant what I got over here, that's 5 by 2, I can easily remove it out, and what I can place? I can place 3 by 2 to say all is well. So what is all is well condition? That is this left hand limit is equal to right hand limit, which is equal to your f of x equal to 0. So let me finish the first part of the problem. I would say here, since limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x, but it is not equal to 5 by 2, which is equal to f of x equal to 0. Perfect. Whatever I am getting, I am summarizing it. So what it tells me, which imply f of x is discontinuous at x equal to 0. So what we got? We got it is discontinuous. So we need to proceed further. Suppose the function is continuous, stop. This will have no meaning. But now since I am getting it is discontinuous, yes, I need to proceed further. Given what? If function is discontinuous, then you need to redefine it to make it continuous. So once I get this, I must say here, since here see, this is equal to this, which is not equal to this. So obviously it is, you can say, hence it is removable type of discontinuity. So since it is removable kind of discontinuity, what you have to do? You have to make situation better. You need to make situation where you get the value for this is equal to this is equal to this. So this is making problem here, right? So what I will do to make my situation better? I will remove this, and instead of this, what I will place? 3 by 2. Perfect. So I will say hence hence it is removable kind of discontinuity. We define. So we say here, this is very important. So we redefine f of x as f of x equal to, so here see this 5 by 2 is making problem, right? So let me remove it to make my situation better. So what I will do, instead of 5 by 2, I will place 3 by 2, and the entire function will remain same. So I say here, so we redefine the function f of x as this to say f of x is continuous at x equal to 0. So this is end of the problem. Okay. Here we have another situation. Here if you see this function, here let us discuss this problem. Let us analyze this problem. Discuss continuity of the function. This is the function which is given to me. So I need to discuss continuity how I used to discuss before. So this is the first part of the problem. Let us go to the second part of the problem. The second part of the problem tells me if the function is discontinuous. They are not sure the function is continuous or discontinuous. They are saying if suppose the function is discontinuous, you state the type of discontinuity. Okay, so let's proceed. We understood this problem. What's supposed to be our plan? Let's proceed further with our proper strategy. Okay, so over here, this is what is the function which is given to me. And now if you see this function, we have modulus. You see there is modulus. Now what does it mean? Now over here, this modulus tells us, so suppose you have mod x, here it is giving minus x. So this mod x is giving minus x for all values. Here see we talk in terms of 0. So we say it is negative x for all x which are less than 0. Then we say it is x for all x which is greater than 0. So are you people understanding here what is happening? What this mod x tells us, it will be negative x for all the values of x which are less than 0. Here you are getting x for all the values which are greater than 0. Fine. So, with this concept, let us proceed further with our problem. What I will do is, the moment I get any problem with the mod, what I will do is, I will rewrite my function. So, here when I start with the solution, I will rewrite my function. So, my function over here, what I am getting, using this conceptual clarity, I will say here it is x minus x upon x. See, the mod x value is minus x here. So, I am saying for all x less than 0. Any doubt here? Perfect. So, when I proceed further, this x cancels and I will get minus 1. I will go to the second condition. The second condition is x upon x. So, when you get it, when your x is greater than 0. And the third condition what I have there, that is equal to 1 when x is equal to 0. So, here x cancels, you get it as 1. Perfect. So, here this function we are rewriting in terms of this. So, basically if I want to make it short, I will say it is minus 1 when x is less than 0, it is 1 when x is less than 0, it is 1 when x is greater than 0, and it is again 1 when x is equal to 0. See, now you don't have to do anything over here. This is actually, here see, this is all the values less than 0. So, this is my left hand limit, this is my right hand limit, and this is f of x equal to 0. The values are in front of you. Are they equal? Obviously not. So, what I will say over here is, I will say limit x tends to 0. Because we are discussing continuity at x equal to 0. So, now over here, so f0 minus f of x, which is equal to minus 1, which is not equal to 1, that is limit x tends to 0 plus f of x. So, we are getting the condition where my left hand limit is not equal to right hand limit. So, hence I will say the f of x is discontinuous at x equal to 0. Now, over here, I am saying it is discontinuous at x equal to 0. And if you look at the problem, nowhere it is written discuss continuity at x equal to 0. Then how I came to know that I need to discuss continuity at x equal to 0? Look at the function. Where there is break point, the critical points which are given to you, that is x not equal to 0, x equal to 0. So, this is telling you that you need to discuss continuity at x equal to 0. So, further we are discussing continuity at x equal to 0. Let us proceed further. Since it is discontinuous, I need to proceed further. Okay. So, what is further part? So, if it is discontinuous, there will be two kind of discontinuities. One, removable kind of discontinuity. Second, non-removable kind of discontinuity. So, you can see here, this is the second kind of discontinuity, that is non-removable, or you can say irremovable kind of discontinuity. Why? Because your left hand limit is not equal to right hand limit. So, I will say hence it is irremovable type of discontinuity. Okay, now over here see, it is mentioned state type of discontinuity. So for this statement of yours, there are marks. So see that, please write this. Hence it is irremovable kind of discontinuity. Why? Because it is clearly mentioned in your problem that you are need to write what kind of discontinuity it is. Okay. So here in this second case, we discussed continuity in this kind of problems where left hand limit is given, right hand limit is given and x equal to 0 value is given. Whereas in the previous case, that is case 1, we discussed something like this, where your left hand limit is equal to right hand limit, but it is not equal to f of x equal to a. Okay. So this note, let me proceed with the third case of this particular concept.
Prudent Scholars, powered by Lupin Pharmaceuticals.